So welcome back to Objective 1 here on Hyperbolas. Let's get a better grasp on the details of the hyperbolas, like the points, the vertices, the foci, and the asymptotes here. Okay, before we do that, remember that what we said for the locus definition, that if we subtract the distances away, the distance from, well, let's look at this picture, any point that is on a hyperbola to the two foci, if I subtract that, it's supposed to be constant. The distance is d2 minus d1 has to be constant. Let's see what that's got to be equal to, all right? So take a look at this diagram. If you put point P at one of the vertices, then figuring out what the distance that it has to be equal to, d2 minus d1, is, well, a little easier. So I just detail this for you. Just take a look right here. Would you agree that the distance from point C, that's the center point, to focus 2 is C? Right? That's what it is. That's how we define it in just the last slide. Would you also agree that the distance from point C to the left vertex, and that's where I can see that D1 is kind of resting right there, that's got to be A, right? I'm going from the center to the vertex, that length's got to be A. So that means in this picture, D2 is equal to, that's the whole blue segment there, it's got to be equal to A plus C. Right? Does it make sense? A plus C, C plus A. I don't think that's different. I think that's the same thing. Okay. Now then, would you also agree that the distance from the center point to F1, which is right up here, that's also C, right? It's again, it's half of the focal length. Now then, D1 right down here, that must be, if this one's C and I take A away from it, it's C minus A. So just in terms of the A's and the C's, we can get how big each one of these D1 and D2 is. Now then, so what we just said, according to the definition, is that D2 minus D1 has to be constant. So let's write down D2 minus D1. Now substitute it in with the expressions that we found with A's and C's. So D2 is supposed to be equal to, we just saw, C plus A. So just put a C plus A in its place. And then minus D1 is supposed to be C minus A. So substitute that in its place. Now distribute the negative sign through those parentheses there. C's are going to cancel, but the A's are going to add up. So this means that D2 minus D1 has got to be equal to 2A. And 2A is the length of the transverse axis. This equals transverse. That's very similar to the definition for the ellipse. When it was D2 plus D1, that was equal to 2A, which was the major axis. For a hyperbola, D2 minus D1 is going to be 2A, same thing, but that length is the transverse axis. And remember this. Look, here we go. A transverse, right? Putting those things together, help you remember it. So if you look on your flow chart there, you see all these points detailed for you. And of course, we're always centering it at H and K. This one is a horizontal transverse axis. That transverse axis is not drawn in there, but remember it goes from vertex to vertex. Its length is 2A. So if I were going to find the vertices, and this is along a horizontal line, I start at the HK, and I move to the right A, and I move to the left A in order to find my two vertices. In order to find my focal points, I would start at the HK again, and this time the C, I need to move to the right C, so that's H plus C, and to the left C, H minus C, but the K stays the same. Now this part's not on there, but if I were going to do the conjugate axis, and that's what I'd want to do to make this little rectangle up here, I would start from the HK again, and then I would move up B units. So that would affect the K, so that'd be K plus B units, and then also down B units in order to make that rectangle. Now look at the asymptote equations. It says K plus or minus B over A times x minus h. This is in, or this used to be in, point slope form, which would have been like this. Y minus k is equal to plus or minus b over a times x minus h. So this is point slope form because the point that it goes through is the center point of your hyperbola, and then I just need a slope. And this slope is I go up b and I go over a. What a marvelous right triangle that is. Up b and right a. So let's look at that with the vertical one. We haven't seen a vertical one yet. So the vertical transverse axis, this time whenever I start from the center point, I'm going to be adding stuff to the k value. So I start at hk. In order to get to the vertices, I'm going to take the a value and add it to the k and subtract it from the k in order to get the two vertices. For my focal point, same thing, add the c to go up, subtract the c to go down. If I wanted to get my conjugate axis, this time it's going to go left-right. It's going to affect the h coordinate. So I'm going to go right-left. That's h plus b and h minus b. Let's look at these asymptotes. So looking at the slope, what do you notice about the slopes of these with the vertical transverse axis versus the previous one with the horizontal? This time, the rise is a, and the run is b. So the slope is b over a. All right. So putting all that stuff together, and aren't you finding that flow chart pretty handy? It's like summarizing all this information for you in a nice compact form. Wait for the bell there. Okay, so the vertices of a hyperbola have those two coordinates. We want to be able to tell if the transverse axis is vertical or horizontal. Again, if it's helpful, draw yourself a picture. But I will notice that the 7s are the same. The y-coordinates are the same. If the y-coordinates are the same, this must be a horizontal line. So this is horizontal. Now, just because some people might want it, let's go ahead and just sketch ourselves out a picture here. And I need a -5, let's say that's -5, 7. Let's say that's 7 right there. And I need a 3, 7. So here are my two vertices, right? Yeah, the vertices. Which means that this thing has to open up like this and like that. Right? And the transverse axis would be that horizontal line there. What is the center of the hyperbola? The center is just the midpoint between those two vertices. So I want to find the midpoint again. -5, I got -5 plus 3 divided by 2, and then the 7 is going to stay the same. So my center point is at -5 plus 3, 2 divided by 2 is -1, 7. So -1, 7, we'll say that's about right there. And then finally, what is the length of the transverse axis? So the only thing that's changing on my transverse axis is this -5 to 3. What's the distance between those? Well, we just subtract them. We go 3 minus a -5. That's equal to 8. And remember, transverse has the a in it, so that's equal to 2a. If I wanted to, I could divide by 2 and I could get my a value being 4. Here's a question. Can I get my foci from that? How about my conjugate axis? Now, I can't get any of that stuff because the only thing that I have are two vertices. So I need at least one other thing. I need maybe the focal points, or maybe I need some endpoints of the conjugate axis. So let's look on how we can relate the A, the B, and the C together for an ellipse. Remember did I say for an ellipse? I might have. I meant for a hyperbola. Okay. But for the ellipse, remember it was the anti-Pythagorean theorem. It was c squared is equal to a squared minus b squared. Let's look what it has to be on a hyperbola. I wonder if it's the same. So take a look at this diagram right here. And would you agree that the segment I just drew in there, that's part of the conjugate axis, that purple segment there, that's got to be B. And this other purple segment that I just drew vertically there, that's part of the transverse axis, so it has to be A. And basically what I've just drawn right here is a right triangle. And what I need to find is this length of that right triangle. Looks like the Pythagorean theorem. So the question is, what is that length? What is that length there? Whoa, what's that circle I just drew? Would you agree that in this circle, the length from that point up to here, that's got to be C, because that's part of the focal length? That's the radius of the circle. Therefore, that point has to be C. So how are those A's, B's, and C's related? That one's just the traditional Pythagorean theorem. That's the C squared is equal to A squared plus B squared. So the hyperbola gets the Pythagorean theorem, and the ellipse gets the anti-Pythagorean theorem. That's pretty interesting. Something to remember. Okay, so now this is going back to that previous question there, and I threw an extra piece of information in it, and that was that the conjugate axis is a 12. Conjugate axis was 12. Conjugate axis has to do with 2b, so 2b is equal to 12, and b's got to be equal to 6. So I got my b value. My a value, I think I found that before. Let's see. Got my center point. My center point was at -1, 7. And length between that was 8. So let's see. 8 equals 2a, so a is equal to 4. Hey, take a look at this. A value is 4, but my b value is 6. The a is not necessarily bigger than the b. The transverse axis does not have to be bigger than the conjugate axis. Okay, so in order to find the coordinates of the foci, I need to find my c. So to find my c, I'm just using the regular Pythagorean theorem. So c squared is equal to a squared plus b squared, which means c is equal to the square root of, my a is 4, so 4 squared, and my b is 6, 6 squared, which is the square root of 16 plus 36, which is 52. C equals square root 52, and I think 4 goes into that 13 times. So 2 square root of 13. So there's the value of C. All right, what did we say? What kind of transverse axis was this? See, the x's are changing, but the y's are staying the same, so this must be horizontal. And that means I'm going to be adding my c value to get the coordinates of my foci to just the x-coordinate. The x-coordinate of the center point. So let me draw one more line here and say that the foci are at -1, that's where I'm going to start, and then I'm going to add and subtract 2 square root 13, and then the 7 is going to stay the same. So here are the coordinates of my two foci. And of course, if you're going to graph that yourself, you would need, you'd have to approximate it in the calculator. All right, so that concludes objective 1, being able to define this hyperbola as a conic section and as an ellipse, and being able to detail all of its parts, like its axes, its asymptotes, vertices, and foci.